Alright, good day viewers. Let us look at the classes of organic compounds. These are the classes of organic compounds: hydrocarbons and non-hydrocarbons. The hydrocarbons are aliphatic and aromatic. And hydrocarbons contains only carbon and hydrogen only. So they are divided into aliphatic, which are called, and this aliphatic can be acyclic or cyclic. These are cyclic or alicyclic and cyclic and aromatic compounds. Non-hydrocarbons are derived from the corresponding hydrogen by replacing one or more hydrogen atoms with atoms of the halogens, either chlorine, fluorine, bromine, and iodine, or group of atoms such as OH, CO2H, NH2, CN. So these groups of bonded atoms are called heteroatoms. All of these, they are called heteroatoms. The heteroatom is an atom or a group of atoms other than carbon and hydrogen. So that is, they are not carbon, they are not hydrogen. So we shall look at them in details. Then we have the functional group. The functional group. Let me underline this. A functional group is an atom or a group of atoms or a chemical bond responsible for the physical-chemical properties of an organic compound. Now, all molecules containing the same functional group undergo similar chemical reactions. The typical functional group is the hydroxyl group, OH. When the hydroxyl group replaces one hydrogen atom in a hydrocarbon, a family of compounds called alkanes is formed. All of these are going to be explained as we continue. Don't worry. Now, we have the homologous series. I'm going to explain all of this later on. We have the homologous series, and we have functional group and examples. We have alkane, alkanes, and alkynes. These three, 1, 2, 3, they are hydrocarbons. So if they contain only the carbon and hydrogen, they are hydrocarbons. But once other element has attached to them, such as heteroatoms, as I've said the other time, heteroatoms, if you could remember, heteroatoms. So they are not hydrocarbon again. Now, but once this is only hydrogen and carbon, they are hydrocarbons. Now, alkane has the functional group having one bond in between. Alkanes, two bond in between. This is the functional group of this, functional group of this, functional group of alkynes. How are we going to know alkanose? The presence of OH. How are we going to know alkanoic acid? The presence of COOH. How are we going to know alkanase? CHO. How are we going to know alkanones? Double bond C, double bond O. I'm going to know alkanoates, COO. I'm going to know amines, NH2, alkoxy, alkane, O. All of these are going to be explicitly dealt with as we continue. Now, these are the functional group of little parts of the organic compounds that we have. Then we have a homologous series. Homologous series. A family of organic compounds with the same functional group is called homologous series. So family of organic compounds with the same functional group. So we call them homologous series. The members in homologous series are called homologues. 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 Now let's proceed. Now about the characteristics of homologous series. 1. The members of the same family can be represented by a general molecular formula. Like alkane now. Alkane has what? CnH2n plus 2. So all the examples are the homologues. Alkane, all the examples of alkane, such as what? Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. The examples of homologues, and they are alkane series. They are in the alkane series. So they have the same general molecular formula CnH2n plus 2. Now, the same thing also goes for alkanes and alkynes. Alkanes is CnH2n. Alkynes is CnH2n minus 2. Now, successive members in a series differ in a molecular formula by what? CH2 group or 14 atomic mass units. Yes. So like now, we have a CH2. Let me demonstrate that here. We have CH2. Sorry, CnH2n plus 2 for alkane. For n is equals to 1, because alkane series is n greater than or equals to what? Equals to 1, only starting from 1. So when n is equals to 1, I have CH, 2 times 1 is 2 plus 2, what? CH4. Now, this CH4, the next member is n is equals to what? 2. And we are going to be having C2H, 2 times 2, 4 plus 2, 6. So that's the first one. This one is what? Methane. This one is what? Ethane. Now let's subtract C2H6 minus what? CH4. 1 C away from 2, we are going to have 1 C. 6 minus 4, we are going to have 2, so CH2. So each member differs by what? Each successive member successive. When is it successive? They are just following one another. Successive. So we have the difference of what? CH2. Let's say the third one. Let's take one more. Methane, ethane, propane. Propane is C3. N is equals to 3. C3, 2 times 3 is 6. 6 plus 2. And that is 8. C3H8. Now, C3H8 minus, what's the first one? What's the one preceding it? Ethane. That's C2H6. C3H6 minus what? C2H6. 3 minus 2, that's 1. C. 8 minus 6 is what? 2. C2H2. You can also see that they are being divided by what? CH2 group. So, or carbon 40 or 14 atomic unit. This is carbon is what? Carbon is 12. Hydrogen is what? 1. 1 times 2, 2. That's what? 14. So that is the reason why we said that what? They are differ by CH2 or atomic number of what? 14. Atomic mass of 14. Now, there is a gradation of physical properties. That is, there is a gradual change from one physical state to another, such as melting point, boiling point, density, and viscosity, as the relative molecular mass increases. Now, volatility is proportional to okay. There's a gradation. There's a gradual changes in the physical state. So these ones, we are coming to this later on. Then they have the same laboratory method of preparation. So they have the same laboratory method of preparation. So in one homologous series now, like in alkanes, all of them, since they have the same general molecular formula, so they are prepared by what? The same similar method. Then each member undergoes similar chemical reactions. Yes, because they are in the same group. The members contain an identical functional group. Yes, identical functional group. Yes. Now the properties depend on the type of the functional group. Yes. Hence, a homologous series is a family of organic compounds that conforms to a general molecular formula in which each successive member differs in molecular formula by CH2 or 14 atomic mass units. Now, let us check the other side. Okay, we have a question here before we move to that. Now, all right, let's look at this example. Methane CH4 is the first homologue in the alkene homologous series. Yes. The question continues in this way. Determine the molecular formula of the second homologue in the series. What is going to be the second homologue? That's going to be what? C2H6, as I said the other time. Determine the relative molecular mass of the third homologue in the what? In the series. Alright. The molecular formula differs by what? CH2. Since in the first series we have what? CH4. The second member is going to be what? CH4 plus CH2 is going to be what? C2H6. Are you following? Now, what is going to be the relative molecular mass of the first homologue in the alkene series? The first homologue is 12 plus 4 times 1. Because this is 4. 4 times 1 is what? 4. 4 plus 12, that's 16. So, in the third member, this is actually the first member. This first member is the first member. So, the second member is going to be don't forget we said they are divided by what? CH2, which is 14. So the first member is 16. So 16 plus 14 is going to be the second member. The third member is going to be 16 plus 14 plus another 14, and that's going to be what? 44. So that's just it. You can have some practice question here. What are homologues? Just to evaluate yourself. Then the molecular formula of the second member in the alkyne homologous series is C3H4. The molecular formula of the second member in the alkyne, don't forget the formula CnH2n. So the molecular formula of the second member is C3H4. Don't forget about the alkyne, alkynes are Cn, H2n, where n is greater than or equals to 2. You always start from 2. So, and that's sorry, this is alkene. About the alkyne is Cn, H2n minus 2. So n is always equal or greater than what? 2. That is always starting from 2. Unlike alkane that is starting from what? 1. So, and don't forget about the homologous series, they are always divided by CH2. So now if they now give you that in this question, they said the second member is C3H4. What is the first member? The first member is what? C2H 2 times 2 4 minus 2 2. So C2H2. The first member is going to be what? C2. You are starting from 2. C2H 4 minus 2 is 2. C2H2. So if you want to talk about the next member, which is going to be the second member, this is the first member. The second member is going to be what? Just add what? CH2, which is going to be you understand? That's going to be what? C3H4. Or if you want to better do it, when n is 3, C3. 2 times 3 is 6. 6 minus 2, 4. So you are still going to get the same. This is the second member. So determine, the question has said determine the molecular formula of the first homologue. Even you can use the formula direct to get your answer. Then determine the molecular mass of the third homologue. So also you saw the formula to get it direct like that. Now let's move to the characteristics of organic compounds. 1. The type of bond. The type of bond there is what? Is covalent. The type of bond is covalent. So we have different type of bonds. We have ionic, or electrovalent, we have a dative, we have a dative covalent bond, which is the sharing of sharing of atoms. So by one participating atom. So sharing of electrons rather by one participating atom. Then number two, we have a nature of bonds. Nature of bonds. So the force of attraction holding covalent molecules are the weak van der Waals force. Therefore, organic compounds are generally gases, volatile liquids, and solid with low melting point. Now we have the shapes of molecules. The shapes of molecules, covalent bonds are rigid and highly directional. Hence, organic molecules have definite shape. Then isomerism, they exhibit a characteristic called isomerism. That is a phenomenon in which two or more compounds have the same molecular formula but different structural formula. That's isomerism. Then they have another property called solubility. Organic compounds are generally insoluble in water, eh, except alkanols, alkanoic acid, and amines with low molecular masses. Now, organic compounds are only soluble in organic solvents like propane or acetone, etc. So, organic compounds can be dissolved in organic solvents, while inorganic compounds can be dissolved in inorganic solvents. So, like dissolves like, right? Then the next point here is conductivity. Organic compounds do not form